Okay, for the second part of this analysis, part 3 of the assignment was split into two parts, one analyzing x motion, that was Alex, and one analyzing y motion, which is me, Nick. And then, so for this part of the analysis, I chose to make the points on the graph 5 frames apart instead of 1, so that the effect of human error in selecting the exact point of where the ball is less prevalent, and so that the blurriness that comes with a fast-moving ball and the frame rate that we chose to film at is less important. This does come with a trade-off that the grass is technically less precise. However, for modeling the motion of the ball, it is more accurate to the real-world motion of the ball in the sense that it is more relevant data, and the minute details between the positions of one frame to the other I didn't feel were that important. So this is the actual analysis that I came up with, and this is it on a graph. This is the y versus time graph. So basically, I applied a quadratic fit to this. This was because it best fit the points. And so what do the points the A, B, and C in the quadratic fit actually mean? So they are pretty much the same thing as this equation here. Displacement, basically y, which is the distance from the start. So it's not exactly displacement, but it's close enough for this application. E is equal to velocity 1 times time. That's if you can rearrange this, you can see that bx is equal to that. So b is equal to velocity, the starting velocity, and then time is equal to x. And so 1 over half a, or acceleration in this case, is equal to a, and then x squared times squared. And then plus c, that's the difference between the bottom of this here and 0. So basically what that comes out to mean is that our acceleration is -1 meters per second, and then our b, which is our starting velocity, is 1.3 meters per second. Sorry, I misspoke earlier. I meant to say -1 meters per second squared. So this same fit can be applied to the velocity time graph. So the slope of this models the acceleration. However, the acceleration is also an integral part of here. So a, again, is half of acceleration, which is 1 in this case, and then the starting velocity, which is b, is -7, and then the c, which is the distance from 0, is 1.467. Something that's interesting, although I don't think it actually means anything, is how these two graphs are almost reversed, where they have similar accelerations, just -1, very similar accelerations, and the starting velocity, although it is different, it still comes out to make a very similar graph.